Hey guys, so in preparation for the quiz, I thought it would be beneficial if we did a little quiz review. And if you do have questions on section 3.6, please screenshot your homework and send it to me and be very, very happy to go over it. We won't have a test next week. We're having a quiz next week on Monday, but our third exam will be the following week. So the week of, the week of the 26th, October 26th. Okay, we started off chapter 3 with quadratics. So can we graph this quadratic, find its domain and range? This is our use of transformations. We know that this got shifted to the right 3, and then this tells me that I went down 1. So my vertex is at 3, -1. This 2 tells me that I'm stretching the parabola. So if this is the vertex, if I go over 1, I would normally go up 1, but I'm getting stretched, so I go up 2. And it's the same thing on the left and the right. And normally with a squaring, which is a quadratic, from the vertex, if I go over 2, I would go up 4. But I'm doubling everything, multiplying it by 2. So going up 2, I should go up 8, which is +7. And remember, there is a vertical line right in the middle that acts as the mirror, and that is called the axis of symmetry. The axis of symmetry in this case is x equals 3. And then you would just do your best to graph this parabola. And a parabola is a polynomial, so polynomials of degree 2 or higher have these nice curves. Every polynomial has a domain of all real numbers. And then the range of this, well, the lowest range value is -1, and it goes up to infinity. To participate here really fully, you should pause the video and try to answer this question, and I'll reveal the answer here. So this will be the format that we follow here. So pause the video, see if you can answer this question, and see if we're right. Does G have a max or a min? And find it. Well, it's the +3 is the leading coefficient, so that means it is facing upwards. So that means it has a minimum. It has a minimum. And to find it, since it's a parabola, I can always do -b/2a. So -b/2a produces 1. That's the x value of the vertex, or the minimum. I plug in 1 to find y, and I discover that I get 8. G of 1 is 8. Don't ever say g of x is 8. G of x is this. G of 1 is 8. So the ordered pair 1, 8 is where this vertex is, which happens to be the minimum. So the minimum is 8, and that occurs when x is 1. What about this one? Can you determine this polynomial's end behavior? Pause the video and find out. Well, the degree is 9, which means it is an odd degree, so the end behavior changes when you look to left and right. The leading coefficient is a negative number, a -4. So when x gets really, really big, so in other words, when you go to the right, this -4 will bring it down. So it falls to the right. And again, since the degree is odd, whatever it does on the right, it does the opposite on the left. So that must mean that it will rise to the left. Rises to the left. Determine the zeros, their multiplicity, and how does that impact the graph? Pause the video and answer. Let's see, f is a 2, 5, 6 degree polynomial, so I'm on the lookout for 6 zeros, and it's already in factored form. -4 does not tell me anything about the zeros. That's just acting as a stretch, a vertical stretch. This tells me that there is a zero of -8/3, and it only occurs once, so it has a multiplicity of 1. And since the multiplicity is odd, which is the number of times the specific zero occurs, it occurs an odd amount of times. That means that when this polynomial is graphed, it passes through the x-axis at -8/3. It passes through to the degree of which the multiplicity is. So the multiplicity is 1, so it would pass through the line as if it were a first degree polynomial. In other words, a line. It kind of looks like a line. 5 is a 0, and that occurs 3 times. So it has a multiplicity of 3. 3 is an odd number, so the graph passes through again. when x equals 5. It passes right on through, but it doesn't pass through as if it were a line. It passes through as if it were a third-degree polynomial. So that's what's called an inflection point. It goes up and then it curves a little bit, but it continues going up. It does pass through. Our final zero is -2, and that occurs 2 times because of the exponent. And that's an even amount of times, an even multiplicity. So now it does not pass through. What else can it do? It is just tangent to that point at the x-axis, or it turns around. And the multiplicity is 2. It behaves like a second-degree polynomial, which is a parabola. So it kind of looks like a parabola at that x value. Use synthetic division to find this. Pause the video and find out. I hope you paused and did it. The answer is -61. You have to follow the directions. So if it says use synthetic division, you must use synthetic division. Otherwise, I just cannot give you any credit. -3 would go into the window, and the coefficients go up here. Remember, 0 is necessary because I need a placeholder. I have 2x to the third, and then it's x to the first. So I have 0x to the second. I need that placeholder. So you drop down the 2, you multiply, I get -6, add, you get -6, multiply, you get 18, add 17, multiply, -51, add -61. -61 is the remainder, and that is the value of the function when x is -3. Find all zeros of the polynomial f, and you're given a little sneak peek right here. So pause the video and find out. Well, it appears that -5 is a 0, but looks can be deceiving. But it looks like -5 is a 0. So I will plug in -5. That's my best shot. I'll plug it in to synthetic division and look at my remainder. It's 0. So now I know that -5 is a 0. I'm looking for 3 more because the degree is 4. I'm looking for 3. So with this new polynomial, x to the third plus 4x squared minus 6x minus 27, I do synthetic division again because it looks like -3 is also a 0. So I plug in -3 and I get the remainder of 0. So now I know that -3 is a 0. And the resulting polynomial is now a quadratic. Remember, you always go down 1 degree. And this quadratic is not factorable, so I can always use quadratic formula. And I get these final 2 answers. So find all the zeros of this polynomial. We've got it. One of the zeros is -5, one is -3, and the other 2 are this quadratic number right here. These are all real. So there are 4 real intercepts. 4 x-intercepts, and only 3 of them are shown here. The 4th one is off the camera somewhere. The intermediate value theorem. Given this, what do you think is underneath this blue box? Pause the video to think about that and come up with an answer. Well, if f of -1 is -10, and if f of 2 is 17, then I'm guaranteed, I absolutely know that there is at least 1 0 between -1 and 2. Because I go from a -10 to a positive 17, at some point I must have crossed over the x-axis, and that's a 0. This only works for continuous functions, and this is a polynomial which is continuous. Pause the video and answer this question. Well, this is Descartes' rule of signs. If you count the sign changes, this has 2 sign changes, from -3 to +4, and then from +9 to -3. So there are 2 or 0 positive real zeros. You always go down by an even number. And to find the negative real zeros, you type in -x into this function, and you get this. Whoops, this is the wrong function. I forgot I changed it. Hold on 1 second. Come on. If you type in -x into this function and simplify, you get this. And there are 3 sign changes. So there are 3 or 1 negative real zeros. So this guarantees me, Descartes now tells me that there is at least 1 negative 0. The degree is 7, so I'm looking for 7. But I know at least 1 is negative, maybe 3. But 1 or 3 are negative. And our final one, create a function with real coefficients. That's a degree 4. With the following information. I know, wow, they gave me 3 of the zeros, and they told me that f of negative 2 is 800. Well, pause the video and find out, please. I hope you paused. If 2 is a 0, then x minus 2 is a factor. If 0 is a 0, then x is a factor. If negative 4i is a 0, then x plus 4i is a factor. And since I know that there are real coefficients, negative 4i must have its conjugate to cancel out, which is positive 4i. So that means positive 4i is also a 0 or a root. So that means x minus 4i is a factor. And now I multiply it out. Distribute the x, multiply these two, I get these two binomials, multiply them, and I get this. So now this is my best guess, that f equals this, but question mark, I don't know. Because what does f of negative 2 equal? Well, f of negative 2 equals 160. It's supposed to be 800. So 160 is just 1/5 of 800. So I'm going to take this polynomial and multiply it by 5. And I have my answer right there. So this doesn't cover everything that could be on the quiz, but anything that's in the homework could be on the quiz. But good luck and have a great weekend.